Hey everyone, today we are looking at section 8.3, which is going to be solving right triangles. So what we're going to start with here is we're given that the trig ratio for cosine A is equal to 0.6. And we are trying to determine which angle in this triangle is angle A. So what we're doing here is going to directly relate to what we did in the last video with section 8.2. I am looking at, starting off, I'm going to put my SOHCAHTOA over here in the corner. And if we look at this, we see that cosine is the adjacent sine over the hypotenuse. So my adjacent sine over my hypotenuse, I want to equal 0.6. So the first thing I'm going to do is I'm going to look over here, I'm going to label my triangle. Since cosine is adjacent over hypotenuse, my hypotenuse doesn't change from angle 1 to angle 2. My hypotenuse is always my hypotenuse. So I'm going to set up the cosine of angle 1 is going to equal my adjacent side over my hypotenuse. So the side that is adjacent to angle A is 3.6. So I'm going to do 3.6 over 6. Then I'm going to set up the other ratio for the cosine of angle 2. Okay, the side that is adjacent to angle 2 is 4.8. So I'm going to do 4.8 over 6. So then what we're going to do is in our calculators, we are going to put 3.6 divided by 6, which is going to give us 0.6, and 4.8 divided by 6, which is going to give us 0.8. So now I want to look and see which angle has the cosine ratio of 0.6. And I see that cosine of angle 1 does. So that means that angle 1 is angle A. All right, any questions? Go ahead and make a note of that. All right, so what we're looking here is the biggest part of what we're doing today is looking at the relationship between the sine and what is going to be our inverse trig functions. Okay, so when we look here, I have the sine of the angle was going to equal the ratio of the sides. So we talked yesterday saying that if this was the sine of 20, that was a number and it couldn't be broken apart. But that I also told you that with this section, we were going to be looking at trying to find the measure of angle A. So when we find the measure of angle A, we are going to take the inverse. And this little -1 here does not mean sine to the -1. That is the notation to show that it is the inverse function. So this will make a little more sense here in just a second. So what I want you to do in your calculators is do 1 divided by 2, hit equals, and then do second and then cosine. And you'll get the inverse cosine of 1/2, which should give you 60 degrees. If you have a 2-line calculator, you will do second cosine 1 divided by 2, close the parentheses, then hit equals. But everybody should get 60 degrees. So what I'm looking at here is if I kind of sketch this triangle out, I know that I have a 60-degree angle. So my triangle is a 30, 60, 90, right? Now, the cosine ratio was 1/2. Well, if I make the short leg of my 30, 60, 90 triangle 1, and that would make the hypotenuse, remember in your 30, 60, 90, its hypotenuse is 2 times your short leg, so this would be 2. So the cosine ratio is adjacent over hypotenuse, so it's 1 over 2. So that's where this comes from. The cosine of 60 is 1/2. The inverse cosine of 1/2 is 60. So that shows you the relationship between the angle measure and the ratio of the sides. So go ahead and put this one in your calculator. So again, your single lines, you're going to do 9 divided by 20 and then hit second sine, and you should get 27 degrees if you round to the nearest whole number. And then if we do the inverse tangent, do 3.2 second tangent, you're going to do, that is going to equal 73 degrees. One thing that I want to point out is if you try to put this in your calculator upside down, if you do 20 over 9 and then do your second sine, it will give you an error. So if we have sine inverse of 20 over 9, it's going to equal an error. That is not a calculator problem. Okay, the calculator is telling you, hey, you did something wrong. Okay, because sine is opposite over hypotenuse. What you've said over here is that your opposite side is longer than your hypotenuse, which doesn't happen. It does not work. So you will continue to get an error anytime you try to do a sine or a cosine or the inverse sine or cosine of a function that is greater than 1. Okay, so or 1 or greater. Your hypotenuse has to be bigger than your side length. All right. So if there's any questions on that, please make sure that you make a note of it somewhere on your paper. All right. So let's go ahead and take a look at our first example here, our first real example. When we're looking at angle R, that's the angle that I'm trying to find the measure of to the nearest whole number. So I'm going to put an X right here in angle R. So the first thing that I'm going to do is I'm going to label my triangle. So this is my adjacent side and my opposite side. And again, I'm going to kind of just write my SOHCAHTOA up here at the top of the page. Okay, so opposite and adjacent is going to be my tangent function. So I'm going to do the tangent of X is equal to my opposite side, which is 8.9, over my adjacent side, which is 3.1. Okay, now, if you guys remember in your algebra classes in the previous years, when you have found an inverse function, like you had y equals 7x plus 2, and you found the inverse by switching the x and the y and then solving again for y, that's basically kind of what's happening here. When we take that inverse function, we are switching our sides here. Okay, so this is going to be the inverse tangent of 8.9 over 3.1 is going to be equal to x. When I put this in my calculator, you should get 71 degrees when we round to the nearest whole number. All right, I'm going to do the same thing here for part B. I'm looking for the measure of angle P, so I'm going to write an X in there. So I'm going to color in my angle. I'm going to label my sides as hypotenuse and adjacent. So A and H is my cosine. So I'm doing the cosine of angle X is equal to my adjacent side, which is 6.7, over my hypotenuse, which is 8.3. Okay, again, in order to get X by itself, I'm going to take the inverse. So I have the cosine inverse of 6.7 over 8.3 is going to be equal to X. When we put this in our calculator, you should get 36 degrees. Okay, so again, whenever we're finding the angle measure, we are going to end up using that inverse trig function. Oop, wow, jumped all the way down here. Okay, so when we look at the next example, same thing. I'm going to color in the angle and label 14 as my hypotenuse. X is my opposite. So again, I'm going to write my SOHCAHTOA over here. So I see O and H, so that is my sine. So I'm going to do the sine of my angle, which is 33, is equal to my opposite side, which is X, over my hypotenuse, which is 14. Okay, to get X by itself, we're going to multiply both sides by 14. So X is going to equal 14 times the sine of 33. When you put this in your calculator to the nearest tenth, we're going to go ahead and just round this one to tenth. It doesn't say where. But you should get 7.6. All right, we're going to do the same thing over here. Color in the angle. Label 29 as my hypotenuse. 24 as my opposite side. So again, I'm using sine. So it's the sine of my angle, which is X, equals my opposite side, which is 24, over my hypotenuse, which is 29. Again, to get X by itself, we're going to take the inverse of both sides, or not the inverse of both sides, but use the inverse function and put that in the calculator. You should get to the nearest whole number. So we're going to round. Degrees are almost always rounded to whole numbers. If you're not told, round a side length to the nearest tenth. But what's important about this slide is I want to make sure that you see the difference between finding an angle measure and finding a side length. So when you're finding that side length, that's what we did yesterday. you're using the normal trig function because you have the sign of the angle measure. The angle measure is already given to you. All right. Over here, we're looking for the angle measure, so that is where we use the inverse. So it is very important that you understand the difference between when you're using sine and when you're using the inverse sign. Okay? Let's look at the next one. All right, with this one, we are solving a triangle. When we're solving a triangle, we are finding all the unknown pieces of information. So any side length you don't know, you're going to find it. Any angle measures you don't know, you're going to find those. So I'm going to go ahead and put all of my missing pieces as a variable. So I'm just going to call my side length here x, angle A I'm going to make y, angle C I'm going to make z. All right, so when I look at x, notice that I already have two sides of the right triangle. So I want to know, is there a way that we can solve for x without using trig? And that answer is yes, we can. We can use the Pythagorean theorem. So my a squared plus b squared equals c squared. So your legs are a and b. So I'm going to do 5 squared plus 7.5 squared is equal to x squared. 5 squared is 25. 7.5 squared is 56.25. That is going to equal x squared. These are going to add together to be 81.25. And then when we square root both sides, we are rounding. This tells us to round side lengths to the nearest hundredth. So I'm going to round this to 9.01. So x is going to equal 9.01. Now, one thing that you need to understand is this has been a rounded number. Okay, so I don't want to use that number to find the next one. Okay, if I use that number to find the next one, there's a big chance that my next angle could be wrong, or my next piece of information could be wrong because I rounded this one. Or if you made a mistake here and you use this to find your other pieces, then you've done everything wrong. So what you need to do is when I go to find y, I'm going to go back to the information that I was originally given. So 5 is my opposite side. 7.5 is my adjacent side. Opposite and adjacent is tangent. So I'm going to do the tangent of angle y is equal to my opposite side, which is 5, over my adjacent side, which is 7.5. Okay, so to solve for y, I'm going to do the inverse. So inverse tangent of 5 over 7.5 is equal to y. And when you put this in your calculator, you're going to get 34 degrees. I'm going to do the same thing for angle z. But for angle z, 5 is now my adjacent side and 7.5 is my opposite side. So the adjacent and opposite switch. So I'm going to do the tangent of angle z equals my opposite side, which is 7.5, over my adjacent, which is 5. Take the inverse of both sides, or not, I keep saying that, but take the inverse function is what we're going to use to get z by itself. And when we put that in, we get 56 degrees. Now, what you want to notice is that these two angles, z and y, are complementary. They add to 90 degrees. Okay, since we have a right triangle, these two angles should add to 90 degrees. All right, so this is a great check to make sure you did it right. All right, if you are solid on your trig and you know that I'm going to get this right every time, then you could do 90 minus 34 and get 56. The other thing, but if you're not super solid on your trig, then you want to make sure you do both functions, because if you get two answers that don't add to 90, then you know you did something wrong somewhere, and then you can go back and do your checks. Okay, redo your problems, make sure you label things correctly, and move forward from there. But again, if you're really strong in your trig, then you can just do 90 minus 34. That will give you the 56. But if you do something wrong, then both angles are wrong. All right, any questions on that? Go ahead and write that down now. All right, so with our last example here, we have San Francisco's Lombard Street is known as one of the crookedest streets in the world. Okay, the road has 8 switchbacks that were built in the 1920s to make the steep hill passable by cars. So Lombard Street kind of does this. It zigzags back and forth to get down the hill because it is what did I do? Is a very large hill. Oh, I know what I did. Sorry, hold on. There we go. Okay, it is a very, very, very large hill and a very steep hill. So this says that the hill has a percent grade of 84%. So the first thing we need to do is write down what that means. So a percent grade means that for every 100 horizontal feet, there is a vertical rise of, in this case, 84 feet. So whatever your percentage is will be how far it rises. So what that looks like is if we draw the right triangle, it means that if I have a grade of 84%, that means for every 100 horizontal feet here is a vertical rise of 84 feet, which will go here. Okay? So then the next question is what angle does the hill make with the horizontal line? So this is what I'm looking for. Now we can solve like normal. We color in the angle. This is our opposite side, our adjacent side, and we solve. Okay, opposite and adjacent is going to deal with tangent. So it is the tangent of my angle, which is x, equals my opposite side, which is 84, over my adjacent side, which is 100. I'm going to take the inverse tangent to get x by itself. And I am going to get 40 degrees. All right, so please know that a percent grade is actually really important. It is something that is used frequently by truckers. If you've ever traveled in the mountains, you will see that they have signs warning the truck drivers that, you know, there's a 12 or 15% grade coming up, so it allows the trucker to slow down in advance if he's going downhill, or maybe even speed up a little bit if he's going uphill, so that he can slow down or speed up the weight of his truck to make it up or down the hill. So percent grade is a very real world thing. If you guys have any questions, please write them down and I will see you guys in class.